Hello future MDs, today we're going to study organic chemistry. This is an overview lecture wherein we'll learn about various functional groups of organic compounds. Our lecturer here is Miss Cruz. She's a graduate of major in chemistry for technology at Marikina Polytechnic College. I'd like to thank her for letting me share this with you. Before we start, please consider subscribing to this channel if you find the contents helpful. Yun lang naman. Thank you so much. Let's start.
Let's define first. Okay, organic chemistry is defined as simply as the chemistry of carbon. Okay, carbon compounds. This does not include oxide carbon. Example of that is we have carbon monoxide, carbon dioxide, and compound with carbonates, and compound with CN or the cyanides. Because this one, the carbon monoxide, carbon dioxide, carbonates, cyanides, this one is inorganic compounds. They obtain from the non-living system. Organic compounds can be natural or synthetic. Of course, when we say natural organic compounds, refers to those are produced by plants and animals, living things or living system. Of course, when you say synthetic, compounds are produced in laboratories. For example of this one is the detergent, the chemical dyes, and other industrial chemicals or chemicals that do not occur naturally. Okay, so those are the examples of synthetics or the difference of natural and synthetic compounds. And another one, organic compounds classified by functional group. Okay, this is the hydrocarbons, compounds containing oxygen, and compounds containing nitrogen. Okay, in hydrocarbons, hydrocarbons contains two elements only. Okay, that is the carbon and hydrogen. Okay, and these are the examples of alkene, alkane, cycloalkane, aromatic hydrocarbons, alkyl halides. And in containing oxygen, we have alcohol, aldehydes, ketones, okay, carboxylic acid and ester. Okay, and we have containing compounds that containing nitrogen. That is the amine and amide. Okay, so let's start with hydrocarbons. So hydrocarbons, we have alkanes, alkenes, and alkynes. In hydrocarbons, alkanes, okay, yung suffix na ginagamit is KNE, alkenes ENE. Okay, alkyne is YNE. So we have, let's first discuss the alkanes. So alkanes are saturated hydrocarbons that contain only single bond. Ibig sabihin, sa given equations, wala tayong makikita double bond, triple bond in the molecules. Alkanes have the general formula of CN. This is the general formula of alkanes. Okay, CnH2n plus 2, which is the N, this one, the N here is the number of carbon atoms. And the example of alkanes is methane. Methane is the simplest hydrocarbon. And another one is we have ethane, propane. Okay, so ma-identify natin if the hydrocarbons is alkanes, alkenes, alkynes, okay, because of their ending, A and E. And in alkanes, remember, walang double bond, walang triple bond. In a given structural formulas, you can see the single bond only. Okay, next one. The carbon-hydrogen bond of alkanes are nonpolar. Okay, so when we say nonpolar, of course, the only forces of attraction between nonpolar molecules are weak intermolecular forces or yung London dispersion forces, okay, which is strength increases as the mass of the molecules increases. So examples of alkanes, okay, the number of C atoms, we have 1, okay, that is methane, 2, ethane, and so on. So we have alkenes and alkynes. Alkenes and alkynes. This one contain carbon atoms attached to less than 4 atoms and refers to as unsaturated hydrocarbons. So The difference between alkenes and alkynes is alkenes, yung alkenes, it contains double band. And yung alkynes, it contains triple band. Okay, alkenes and alkynes contain carbon atoms, pero yung pagkaibahan lang nila is alkenes contains double band, and alkynes, it contains triple band. Example is the ethene, okay, and alkanes is ethine. To name a straight chain alkene, this one, straight chain alkenes with only one double band, number the carbon of the parent chain such as the carbon with double band, okay, has the lowest possible number. Okay, so for example of this, 2-pentene, 1, okay, and 2. Same rule with the alkynes. So we have this one, 2, 2-pentine. Next one is cycloalkanes. Cycloalkanes are which the carbon atoms in a ring or cyclic structure. Okay, arranged in a ring or cyclic structure. And cycloalkanes, they are usually represented as polygons, which is each corner, this one, for example, each corner, okay, correspond to the carbon atom. Example of that one is we have cyclobutane, cyclopentane, cyclohexane, okay, cyclopropane, and cyclohexane. And cycloalkanes are named by, okay, paano ba natin pinapangalanan? Okay, the cycloalkanes. Cycloalkanes are named by adding prefix. Okay, so we add prefixes cyclo, okay, we add prefixes cyclo before the name of the chain open compound having the same number of carbon atoms as there are in the ring. Okay, for example, this one, butane. Okay, so since that is cycloalkanes, we add prefixes cyclo. Okay, and cycloalkanes also known as non-polar. Okay, it has low melting point and boiling point. Okay, next one is the aromatic hydrocarbons. Aromatic hydrocarbons, also called arenes. Arenes are compounds that have 6 member carbon known as the benzene ring. Aromatic hydrocarbons are also called arenes, compounds that have 6 member carbon, okay, or commonly known as the benzene ring. Okay, benzene is the simplest aromatic hydrocarbons. It's highly unsaturated. Of course, 6-member ring compound with alternative single and double band. Okay, ito yung tatandaan sa benzene ring, alternative, single, and double band between adjacent carbon atoms. Okay, and chemically unreactive compared to alkenes. They are unreactive. Okay, and in 1865, Kekule proposed the structure of benzenes, which is he proposed that the carbon atom of benzene molecules are arranged in 6-member. Okay, 6-member. This one. This is the structure of benzene. This one. Okay, Kekule proposed that the carbon atoms of benzene molecule are arranged in 6-member ring. This is 1, 2, 3, 4, 5, 6, and with 1 hydrogen atom banded to each carbon atom. Okay, and as you can see, alternative single and double band. Okay, single, double, single, double, single, double. That is according to Kekule. And we have another examples. Okay, we have the ibuprofen and aspirin. Okay, this one, both ibuprofen and aspirin are relatively aromatic compounds. They are non-steroidal anti-inflammatory drugs and analgesic. Next one. So we have alkyl halides. So what is alkyl halides? Okay, they are hydrocarbons in which one or more hydrogen atoms have been replaced by halogen atoms. Alkyl halides have the general formula Rx. Remember, R is the alkyl group, X is the halogen, okay, replacing one of the hydrogen atom. An example of alkyl halide is the ethyl chloride. Okay, ethyl chloride. Example of alkyl halide is the ethyl chloride kung saan ginagamit siya as spray-on local anesthetic to treat athletic injuries. And here are other examples of alkyl halides and their corresponding hydrocarbon origin. For example, is we have methane. Okay, we have chloromethane, or that is the methyl chloride. Okay, methylene chloride, chloroform, and carbon tetrachloride. So, okay, in naming alkyl halides, so we replace the A and E, okay, with YL. So from ethane, ethyl chloride. So we have carbon tetrachloride, this one. Okay, carbon tetrachloride, and we have chloroform. So these two are the common, okay, the simplest common alkyl halides, okay, which is yung chloroform, ginagamit yan as medical anesthetic before, okay, but now it has been found to be a carcinogenic. Tetrachloride also been used in fire extinguishers, the fabric cleaners, as a solvent, okay, but now known to damage the liver. So that is the alkyl halides. Next one. So we have compound containing oxygen. So by the way, in alkyl halides, another one is alkanes. Okay, alkanes whose hydrogen atoms with substituted with chlorine or F. Alkanes whose hydrogen, we have alkanes is substituted with Cl, Cl or F. Cl or F. Okay, so are called chlorofluorocarbons or the CFCs, which is CFCs have been used in dispersing gases in aerosol cans. Okay, foaming agents for plastics and refrigerant. Okay, so and of course we know already that CFCs are known as freons. Compound containing oxygen. Okay, so what are the compounds that containing oxygen? The first one is alcohol. Alcohol are the compounds that has hydroxyl group or OH bonded to carbon atom. Okay, so we have general formula ROH. So malalaman natin yung compound. It's either alkenes, alkanes, alcohol. If alcohol, okay, so bonded with OH. Where R is the alkyl group. Alcohol occur widely in nature and have many industrial, sa pharmaceutical, okay, and biological applications. Okay, an example of alcohol is the ethanol, which is used as fuel additive naman, okay, industrial solvent, ingredients in alcoholic beverage. We have also classifications of alcohols, or alcohols are classified as primary, secondary, and tertiary. Okay, primary, secondary, and tertiary. So this one, the primary, secondary, and tertiary alcohol is depending on the number of carbon. Okay, the number of carbon substituents bonded to the hydroxyl bearing with the carbon. So we have the primary 1, secondary we have 2, so tertiary is of course 3. So we have examples, another examples. Okay, aside from ethanol, how do we name alcohol compound? So alcohol get their names by appending the suffix OL. Okay, OL, suffix, sa huli, to the hydrocarbons. So for example, we have methane, okay, becomes methanol. So the A and E, okay, so replaced by OL, or the E rather, or the E replaced by OL. Okay, so methane, methanol. Okay, so since that is alcohol. Okay, what are the uses of alcohol? Alcohol are sometimes used as alternative fuels, okay, and as octane enhancers in automobiles fuels, okay. Ethanols is common examples of alcohol. Ethanol is combined with gasoline in 1 to 9 ratio to produce gasohol. Another one, wines. Our wines contain ethyl alcohol and varied percentage. So next one is ethers. So ethers is we have ethers, okay, are organic compound with two hydrocarbon groups are bonded to the same atom of oxygen. If alcohol, okay, has a formula of ROH, the general for ethers is ROR, where R may be the same hydrocarbon group as R or different one. So ethers is like alkanes. They are not very reactive compounds. So since they are not very reactive compounds, they commonly used as solvent. So we have simple ethers that contain similar group are named by counting the identifying and organic compounds with adding the word ether is one. For example, is we have diethyl ether, okay, accounts from two ethyl. Okay, this one and this one. Okay? So, same lang siya, pero magdadaglag lang tayo ng word na ether sa huli, which is diethyl ether, okay, is extremely flammable and sometimes can exhibit explosive properties. Another example of ethers is we have epoxy ethane. Okay, so next one, we have aldehydes and ketones. Okay, aldehydes and ketones contain the carbonyl group. The difference between aldehydes and ketones are the substituent on the carbonyl group. Okay, this is the general formula. So this is the carbonyl group, right? Okay, this is the general formula of carbonyl group. Okay, we have also aldehydes. This one. Okay, and we have ketones. It says the difference between the aldehydes and ketones are the substituent on the carbonyl group. Okay, aldehydes, it contains R and H. Okay, R and H. In ketones, same R. Okay, both are groups. So that's the difference. Aldehydes, R and hydrogen or H group. Okay, sa ketones, both are groups. Okay, aldehydes named after replacing the terminal E, ending E, of the corresponding alkene name with al. Okay, nire-replace natin yung ending na E into al. That's in aldehydes. In ketones, okay, the suffix O, N, E is used. For example, in aldehydes, we have ethane, okay, ending with E, right? So in aldehydes, we replace that one in al. Ethane, ethanol. In ketones, we have the suffix ONE. Okay, so for example, it's propane. That will become propanone in ketones. So that is the aldehydes and ketones. So next one, aldehydes and ketones. Okay, so many common odors and flavors come from aldehydes and ketones. Okay, so for example, in aldehydes, we have cinnamaldehydes, which is cinnamaldehydes come from the cinnamon bark. Okay, we have also vanillin from the vanilla bean. We have citral, okay, that is from lemongrass. In ketones, we have two, the camphor. Okay, camphor, it's come from camphor tree, and we have moscon that is from the mass deer. So next one is carboxylic acid. So carboxylic acids are organic compounds, okay, that contain carboxyl functional group. Okay, and this is the general formula. RC double bond O OH. simple open chain carboxylic acid are named by replacing terminal E of the alkane name OIC. Okay, so papalitan natin yung E to OIC. Carboxylic acid are polar and they can form hydrogen bond with each other. Okay, of course, they have higher boiling points. Compare natin sa alcohol. And carboxylic acid have weak acidic properties. For example of, or common example of carboxylic acid is the ethanoic acid. Okay, this one. Ethanoic acid, that is the acid in vinegar. Methanoic acid, that is secreted by ants, which causes the pain from the sting. And we have acetic acid. Okay, acetic acid, okay, ginagamit siya as coagulant in making rubber. So, we have, these are the common methanoic acid. From methane, okay, so replace natin yung E into OIC, methanoic. Ethanoic, we have propanoic. Okay, and these are their molecular formula. Okay, shortened. This is the structure. So next one. By the way, carboxylic acid, okay, such as we have the stearic acids, okay, so which is ginagamit po yan in make soaps, okay, so organic acids are used in the preparation of many drugs at saka aspirin. Okay, next one is the esters. Esters are organic compounds that have carboxylic acid. Okay, carboxylic acid group in which the hydrogen of the hydroxyl group has been replaced by alkyl group. Okay, and it has a general formula of R, C double bond, OR. So esters are named by first giving the name of alkyl group attached to the oxygen and identifying the carboxylic. In so adding, so we have, okay, in carboxylic we have IC at methanoic, okay, IC acid ending replaced by ATE in carboxylic acid. Okay, so ending is IC, but in esters, okay, so ending is replace IC into ATE. Okay, for example is acetic. Okay, it becomes acetate. So example of this one, example of ester is ethyl acetate. Okay, so esters are responsible for many of the pleasant smells of fruit. So, for example, is the characteristic of smell of banana. Okay, largely come from ester isoamyl acetate. Okay, which is ginagamit yan sa in many food and beverage. Ester have more familiar fruits flavor. Okay, so we have the ethyl acetate, isoamyl acetate. Okay, which is ethyl acetate is most common ester and possibly the one with the widest range of uses. And yung smell niya is fruity smell. Next one, compounds containing nitrogen, that is amines. In amines, the hydrogen atoms in ammonia or NH3 have been replaced by hydrocarbons. Okay, that's in amine. Okay, amine also are classified as primary, secondary, and tertiary. Okay, so and these are their structure. Okay, so in primary we have, okay, R, H, Rn, H2. Okay, secondary we have R2, NH. Okay, this formula. Okay, and tertiary is R3. And since that is classified as primary, depending on the number of organic substituents attached to the nitrogen. Okay. Amines named by alphabetically, linking the names of alkyl group or aromatic compounds. Bonded to the nitrogen, attaching the suffix amine, the name is written in one word, okay, and the prefixes is di and tri, are used when identical group are present. So same lang, syempre, if one, we don't use mono, right? Okay, just write, for example, this one, methyl. Okay, since one lang, hindi na natin sinusulat as mono. Just write methyl and, okay, the suffix amine, methyl amine. If two, we use di. Okay, prefixes di. Okay, and of course, if three, we use prefixes tri. Dimethyl, trimethyl, and suffixes amine. And of course, we have also examples of amines. Okay, so we have methylamines, ethylene, dimethyl, trimethylamine. Okay, so ma-identify natin yung it's either primary, secondary, or tertiary. Okay, okay, depende po yan sa number of organic substituents. Okay, so attach dun sa nitrogen. And we have the amides. I think this is the last. Amides are derived from carboxylic acids. Okay, and it has general formula of RCO and H2. The OH part of carboxylic acid is replaced. Remember, the OH part of carboxylic acid is replaced by NH2 group. Simple amides are named after corresponding carboxylic acid by changing IC in common names. Okay, di ba we have common names and IUPAC names. Okay? If the common names, the ending is IC. Okay, in IUPAC names, the ending is OIC. Okay, the common name is formic acid. Okay, IUPAC name is methanoic acid. In naming amides, we have this. Okay, in common name, IC, right? Okay, so just add amide in the end. Okay, formic acid, okay, in amides, we have formamides. Okay, formamides. Okay, methanoic acid, okay, just replace OIC into amide. Okay, so metanamides. Okay, so that's how to name amides.